Dinosaur Story. Skin appendages. Hi. This time, we are going to learn about structures derived from the skin, such as claws, horns, and feathers. Skin appendages are structures derived from the epidermis and dermis of the skin, such as hair, feathers, claws, horns, and scutes. Although they are not well preserved as fossils, they are as important as skeletons in dinosaur research. Scales and scutes. Scales and scutes are structures derived from the skin. Both fish and snakes have scales, but they are different. The main component of fish scales is bone derived from the dermis, and the main component of the scales of snakes and lizards is keratin derived from the epidermis. As introduced in the previous story, the skin bumps of crocodiles and dinosaurs are bony structures mainly derived from the dermis, called scutes. The shell of the Cenozoic mammal Glyptodon is also a uniquely modified form of scutes. Claws. Claws are rarely preserved as fossils because they are composed primarily of keratin rather than bone. For example, claws can be seen in skeletal specimens of living tigers, but not in extinct saber-toothed tigers and dinosaur fossils. However, through fossils, we know that dinosaurs also had claws. There is a long groove in the middle of the toe bone of the dinosaur. The claw was firmly attached to the bone through this groove. In the toe bone, the muscle scars where the tendons that move the toe up and down are attached is also found. There are several types of claws. The claws of carnivores are sharp and curved. The flat claws of humans and chimpanzees are called fingernails or toenails, and the claws of horses are called hooves. The claws of eagles or hawks are called talons separately. There is a growth plate called the subunguis under the claw, and the shape of the claw changes according to the growth rate of this plate. The primate's subunguis is very small, and humans don't have it, so their nails are flat. We have 5 fingers and toes, but dinosaurs often have fewer. Scholars speculate that dinosaurs had 5 toes at first, but gradually the number decreased. However, in dinosaurs, it's never reduced to 1 like a horse's hoof. The second claw of carnivorous dinosaurs such as Deinonychus and Velociraptor is very large and sharp. It's called a sickle claw because it looks like a sickle. They were able to grab their prey strongly with their sickle claws like eagles. They could retract sickle claws upward to prevent wearing out. Their footprint fossils often show only 2 toes, and rarely 3. It's because the claws didn't touch the ground. The claws of modern cats are very similar. The second toe bone is dented, so the claw can be retracted backward. Since the claws don't touch the ground and don't wear out, they can always be kept sharp. Therizinosaurus had incredibly large front claws that were over 50 centimeters long. It is the largest of the dinosaur claws. With these fearsome claws, they would have been able to fight against large carnivorous dinosaurs. Horns are also structures derived from the skin. Among vertebrates, only mammals and dinosaurs have horns. Horned lizards also seem to have horns, but their horns are a kind of scale that comes from the epidermis and are not real horns. So, which animal's horns are the most similar to those of dinosaurs? Could it be a rhinoceros? Looking at the skeleton, dinosaur horns are made of bone, but there is no bone in the horn of a rhinoceros. It's completely different. If not rhinoceroses, which animal is most like a dinosaur? The horns of deer are called antlers. The center of the horn is made of bone grown from the skull. However, at the end of the breeding season, the connection to the skull weakens and antlers are shed, and new horns regrow each year. It is different from dinosaur horns. Giraffes also have horns. Skin covers the blunt-ended bone that grows from the skull. Their bone and skin never fall out. It's similar in that the horns are made of bone. However, it seems that the horns of the dinosaurs were not covered by the skin. The horns of the pronghorn, native to North America, are covered by the skin over the bony core. The bony cores are maintained throughout life, and the skin gradually turns into keratinous sheath as it grows new each year. It looks a little closer to dinosaur horns than those of antlers or giraffes. The most common horn found in cows and antelopes is called the true horn. Their horns are made of bones in the center and covered with keratin. We found it. Dinosaur horns must have been like this. In particular, the horns of Nasutoceratops, found in Utah, look really similar to those of a cow. Hair and feather. Hair and feather are also structures that come from the skin. And with the discovery of feathered dinosaurs, we learned that dinosaurs had feathers, but their feathers are different from bird feathers or mammalian hair. Feathers have also been found in other dinosaurs. Psittacosaurus is an early form of horned dinosaur found in several countries in Asia, including China. Feathers were found on the tail of this dinosaur. Although it is not clear yet, scholars believe that it is a structure different from the feathers of feathered dinosaurs. Scholars who claim that dinosaurs are the ancestor of birds are more interested in bird feathers than mammalian hair. Dinosaur feathers are called proto-feathers, and these scholars want to know the correlation between these proto-feathers and bird feathers. Feathers come in many shapes. There are feathers for flight, and some feathers make the body streamlined. Down feathers maintain body temperature. And there are also feathers found around the eyebrows and beak. Let's look at the basic structure of a feather. The part corresponding to the root is called a quill and is hollow inside. As the quill goes up, it leads to a solid shaft, and the leaf-shaped veins are supported by barbs and barbules. Scholars hypothesize that the proto-feather has changed into today's bird feathers in 5 stages. At first, it was a hollow thorn, and gradually divided into several strands. Progressively, it had a shaft and barb. Then, after going through a symmetrical feather, it became an asymmetrical feather for flight. Asymmetrical feathers based on the shaft are very important for flying in the sky. Not only the wing feathers of modern birds, but also the wing feathers of Archaeopteryx are asymmetrical. So why are asymmetrical feathers so important for flight? At first glance, symmetrical feathers would be more stable and better. With the flapping of the wings, the air flow changes up and down. During the downstroke, air pushes the feathers up. Each feather rotates around the shaft to form an almost flat surface, with no gaps between adjacent feathers. So the air cannot escape through the feathers, and the body floats upward. On the contrary, when the wing is raised, air pushes feathers down. And as each feather rotates downward around the feather shaft, air escapes through the feathers. So the bird can lift its wings easily. The asymmetry of feathers is for flight. In addition to modern birds, asymmetrical feathers are also found in Archaeopteryx, Microraptor, and primitive birds that appeared in the early Cretaceous period. Dinosaur quiz. Which of the following is not an asymmetrical feather? Number 1 wing feather of birds. Number 2 tail feather of birds. Number 3 wing feather of Archaeopteryx. Number 4 wing feather of primitive birds. The answer is the tail feathers of modern birds. The wing feathers of primitive birds, modern birds, and Archaeopteryx are asymmetrical. The symmetrical tail feathers of birds are used to balance the body. That's it for today. See you next time. Thank you.